All right, how's it going out there, folks? Today's hot topic, talking about classifying sedimentary rocks. The other day, we talked about the formation of them, how they form. Today, we're going to talk about how they're classified to figure out, how to identify them, which one's which. Okay? Beautiful pictures here. Sedimentary rocks make gorgeous formations. These are out in the Midwest. These layers here are sandstones, but you can see they're at different angles. And that's because over time, the planetary winds kind of change direction and blow the sediment at different, positions. And when it solidifies in a sedimentary rock, you get what's called this cross bedding, and it's absolutely gorgeous. This is out in Arches National Park, and again, you can see the beautiful sandstone there with the reddish iron in there. And the wind and water weathering and erosion over time carved out these arches. The more resistant rock, of course, remains. This one is called Delicate Arch because you can see it's got a real thin piece there. So as soon as you can, head on out to, that's in Utah, I believe, Arches National Park, to check that out. There's lots of other ones as well, and it'll blow you away. Totally surreal. All right. So the following slide contains several pictures of sedimentary rocks. They've been separated into 3 different groups based on their characteristics or formation. Observe their characteristics and write down what you think, why you think they were organized this way. So these are the 3 groups. Okay. Hit pause, just jot down real quickly why you think these rocks were put here in group 1. Same for group 2 and group 3. Just a quick, what you observed and why you think they were there. Okay, hit pause, take a minute. Okay, in this first one here, hopefully you notice pieces of different rocks, right, kind of cemented together. And of course, if you have layers, those are different rocks as well. And those pieces are called fragments, right, or clastic rock. So these are all the clastic fragmental rocks that were cemented together. These are a land-derived sedimentary rock. Over here, probably the easiest thing to observe, of course, the fossils. And that's evidence of a past living thing. So they call those bioclastic, right? Biology, the study of life. Well, this is evidence of past life. And on the bottom here, maybe it was a little difficult to see, but these look like crystals. But they're not igneous rock crystals. These form when water evaporates. They're called crystalline rocks, sometimes called precipitates. And it results when water evaporates. And whatever mineral dissolved in that water precipitates out. Okay, so make sure you jot that down. All right, so according to texture, identify 2 major groups of sedimentary rock. Well, there it is. We have the clastic and we have the non-clastic. All right, and how do we differentiate between them? Well, clastic rocks, again, they're pieces of other rocks cemented together. Okay, and they are separated by their grain size. And I spoke about the other day, you can really feel it oftentimes easier than you could see it, right? Our sense of touch is more sensitive than our eyes can zoom in a sense. And just by rubbing the rock, you could pretty much tell what size sediment is in there. All right. The non-clastic rocks are made from those dissolved minerals or plant remains. So they do have 2 very distinct textures and characteristics. This would be like a warm, shallow sea right there where you'd have a lot of evaporation and then precipitation of the minerals. And that's probably a lot of either rock salt or rock gypsum up on the beach there. Okay, here's the chart that you're familiar with, right? Up on top of the land-derived clastic rocks. And what we're going to do is we're going to go down the column here. So the first one is a mixture of all the different sizes cemented together. We call it conglomerate, and there's a sample of that. Going down, it's the same particles, but now they're not rounded, they're angular. They haven't been weathered as much, but it's still similar to conglomerate, but they call it breccia because they don't have those rounded fragments. Further down is your sandstone. Now we are more uniform in size, right? Sand is within this range here, and when that gets lithified, they call it a sandstone. You can clearly see the layers in that sandstone there. And that's a zoom in of the sand grains. All right. Siltstone, even smaller sediments. You can see it's not as grainy looking anymore. It'll definitely feel much smoother. And the smallest of all sediments, clay, makes up the rock shale. All right? So these grain sizes are decreasing as you go across here, and that's because we went down the chart. The bottom part of the chart, right, this is your crystalline or marine type rocks. First one we're starting out with is rock salt, and that should look familiar to you, right, similar to the halite in the mineral lab we had. Keep going down, you have rock gypsum. This is the one they grind up into a powder and cement between that paper, and that's what your walls are made out of. Unless you have a home that's made out of plaster walls, that's different. But this is the prime ingredient in sheetrock. They call it gypsum board. Okay? And then, of course, dolostone. So these two definitely you could see are crystalline chemical. That's a little tougher to see. If you had it in your hand, you'd be able to see it better. But these are the crystalline rocks. And now I'm going to keep going down. There's a limestone. That kind of looks like a bone, right? So kind of an organic look to it. Limestone can be either organic or inorganic, right? It can be either, but both have calcite in them, which means they'll dissolve in acids. So you could easily tell a limestone based on that acid test. And of course, the last one, that's a biologic limestone there. That's a coquina, okay? And the last one, hopefully you don't get in your stocking come Christmas time. That's your coal, and that is a sedimentary coal. This is not the best coal to burn. It burns kind of dirty and it doesn't release as much energy. But if you metamorphose that, we'll talk about that in metamorphic rocks, then it becomes a real energy producer. Okay? All right, so pretty cool color scheme going on with that chart there. Last part I want to focus on is the bioclastic, right? That chunk of coal starts out as trees, right? We call it fossil fuel when you think of coal and oil. Starts out as trees, they die, they decay, and they create what's called a peat. Maybe you've heard of peat moss. If you're planting, sometimes peat moss is good for the soil. It's full of organic matter. And then it gets buried over time, and it gets compacted, and that carbon gets concentrated, and ultimately will turn into a coal reserve. And that's, of course, when they dig down and try to mine out that coal. Okay? So the plant remains get buried, compacted, and turn into coal. Now, interestingly enough, there's coal, lots of coal, they say, in Antarctica. Well, Antarctica doesn't have any plants, really. So why would there be a lot of coal? Well, Antarctica must have been in a different place, right? Closer to the equator, where you had lots of vegetation, and then it must have migrated. And we'll talk about that with plate tectonics. But that's one of the evidence of the dynamic Earth there, right? Because coal needs to form from lots of plants. Lots of plants form in warmer climates. So anyway, we'll talk about that when we get to plate tectonics. All right, so what you guys need to do, try to put the vocabulary from the chart into this column here. Try to organize it. And then there's, of course, some summary questions that follow. All right? I'll meet you back in a minute.